Third problem. Find a comma b such that they provide the limit value. Limit x tends to 0, x times of a plus b cos x minus c times of sin x by x power 5 equal to 1. Now find a comma b. Just you remember, you apply the L'Hospital rule. Answer or solution. Solution. Because if you substitute, because we substitute a comma b values, a comma b value, I mean x value, we get 0 by 0 form in the left hand side. You observe that x 0, here sin 0 0, 0 into something equal to 0 in the first part, here 0, 0 minus 0, 0 numerator, denominator 0. So we apply the L'Hospital rule. By applying L'Hospital rule, limit x tends to 0 given x times of a plus b cos x minus c times of sin x by x power 5 equal to 1. Now substitute x value 0 times of a plus b cos 0 minus c times of sin 0 by 0 power 5 equal to 1. That implies 0 by 0 equal to 1. In the left hand side, it appears 0 by 0. You take cross multiplication, we get 0 by 0. That means the given problem is valid problem. Take a cross multiplication. But in the left hand side, it appears 0 by 0, indeterminate form. This is left hand side is indeterminate form. So we apply the L'Hospital rule. By applying L'Hospital rule, the limit value equal to the given limit value. This limit equal to its derivative limit. So its derivative value becomes x prime UV rule in the first term. Derivative of first function into second function plus second function into derivative of first function 0 minus b sin x. The second term derivative of second term is c times of cos x. Numerator over denominator 5 into x power 4 equal to 1. So once again substitute the x value. What happened? You observe that a plus b into cos 0 plus 0 into minus b times of sin 0 minus c times of cos 0 by 5 into 0 power 4 equal to 1. That implies okay. So substituting limit value, here we get a plus b cos 0 1 next term 0 minus c times of cos 0 means minus c into 1 by 0 equal to 1. That implies a plus b minus c equal to 0 by cross multiplication. But we don't know numerator values a, b, and c, but their relation must be 0. Find a, b, c values. So we get one equation from here. Similarly, we take a second derivative. Once again, apply the L'Hospital rule to the this expression because we don't know a, b, c values. But their product is 0. That means numerator is 0. 0 by 0 is indeterminate form. So once again, we apply the L'Hospital rule. After finding these values, we get a plus b minus c equal to 0. Substitute here, we get 0 by 0 equal to 1 form. So once again, it is indeterminate form. So by applying once again L'Hospital rule for the above limit, we get a derivative 0, b times of cos x means 0 minus b sin x minus x into minus b sin x means minus uv rule. B is a common factor. X into sin bx derivative sin x plus x cos x, cos x derivative minus sin x, minus into minus plus by this is x by derivative of denominator term is 5 into 4 into x cube. 5 into 4 becomes 20. 20 into x cube equal to 1. Once again substitute the limit value. Here limit tends to 0. Substitute the limit in the left hand side. We get minus 0. No need to enter because 0 minus something equal to 0. Same value. Minus b times of sin 0 minus of b times of sin 0 plus 0 times of cos 0 plus c times of sin 0 by 20 times of 0 cube equal to 1. See, in the left hand side, no a's and b's. Sin 0, 0. B into 0, 0. Here 0, 0 into cos 0, 0. Because cos 0, 1. Even though 0 is finite value equal to 0. Sin 0, 0. Numerator 0. Denominator 0. Once again here we get a indeterminate form. So once again apply the L'Hospital rule. Therefore, the limit equal to the derivative of the limit. Limit extends to 0 equal to its derivative minus b sin x derivative cos x minus b cos x minus b times of sin x derivative cos x. Here we apply UV rule. First function take derivative of first function into second function plus x into derivative of second function minus sin x. You write down minus plus into minus minus sin x plus no don't no plus yes plus sin x derivative is cos x c plus c times of cos x c into cos x by denominator derivative 20 into 3 times 20 into 3 times of x square, that means 60 into x square equal to 1. Once again you apply the limit values, routine procedure until we get the denominator as a constant. That implies minus b into cos 0 minus b times of cos 0 plus cos 0 minus 0 into sin 0 plus c times of cos 0 by 60 into 0 square equal to 1. That implies minus b cos 0 1 minus b into 1 1 minus b into 1 plus 1 minus 0 plus c into 1. If you have any confusion, here also write down 1. Denominator 0. That implies simplify the numerator minus b times of minus 2b plus c equal to 0 by the cross multiplication. Minus 3b plus c equal to 0. From this equation c equal to 3b. So that means you observe that this value equal to 0. Substitute this value. This value nothing but minus 3b plus c. Numerator value is minus 3b plus c. Minus 3b plus 3 we get 0. 0 by 0 once again in the left hand side. By substituting limit, we get a 0 by 0. So it is indeterminate form. So one more time, we apply the L'Hospital rule. Therefore, limit extends to 0. By applying the derivative, first term is minus b cos x. Its derivative becomes minus sin x, minus into minus plus b sin x, first term over. For the second term, we have minus b minus sin x minus b times of minus sin x minus of x into sin x derivative. X into sin x derivative becomes derivative of first function into second function, means minus of sin x plus, already minus is there, sorry, derivative of first function derivative into second function into derivative of first function cos x within the braces over. Last term plus c cos x, it becomes minus c sin x by 60 into x square. This derivative becomes 60 into 2 into x. That means 120x. 120x equal to 1. Substituting this value, you observe that substituting sin value, we get b into sin 0 numerator minus b into minus sin 0 minus sin 0 minus sin 0 minus 0 into cos 0 c into sin 0 by 120 into 0 equal to 1. Numerator 0 by 0. Sin 0 0, b into 0 0, sin 0 0 0 0 0 into cos 0 0, sin 0 0, numerator must be 0. We get this value. Indeterminate form. No relation between variables or constants. Indeterminate, not variables. Indeterminate form. So take one more derivative because we get a indeterminate form. Therefore, the limit value is limit extends to 0, b times of sin x derivative cos x minus b times of sin x derivative cos x minus cos x minus cos x minus cos x minus of derivative of first function into second function into derivative of first function plus of minus, it becomes plus x into sin x c times of cos x, last term derivative, by denominator derivative 120 because x derivative 1. Substitute x value, we get a b value. So b into cos 0 minus b into minus cos 0 minus cos 0 minus cos 0 minus cos 0 plus 0 into sin 0 minus c into cos 0 by 120 equal to 1. B minus b times of cos 0 cos 0 cos 0 4 times minus 1 minus 1 minus 1 minus 1, that value 0, minus c times of cos 0 1 by 120 equal to 1. That implies b times of minus b, here minus 4 plus 4, totally plus 4b minus c equal to 120 by cross multiplication. Now 5b minus c equal to 120. Already we know the value of 5b, c value, c equal to 3b. Since from equation 2, 3b equal to c. Already we derived the equation 2, c equal to 3b. Substitute this value, we get, that implies 2b equal to 120. That implies b equal to 60. Substitute this value, substitute this value in the first equation. Substituting b equal to c and c equal to 3b in equation 1, then we get the first equation is a plus b minus c equal to 0. See the first equation in our process. This is first equation, a plus b minus c equal to 0. Substituting equation 2 and b value, we get a value because we required a plus b value is 60 minus c value is 3b equal to 0. A plus 60 minus 3 into b value is 60 equal to 0. That implies a 60 minus 3 into becomes 120 minus 120. 2 times left. 2 times of 60 means 120. A equal to 120. That's all. This is the tricky problem based on the indeterminate form, 0 by 0 form. So next section problem. So next section problem means third infinitive by infinite form. These are the same model. 0 infinitive by infinite also converted into 0 by 0 form. So first problem is show that limit of log x by cot x equal to 1. Next problem, next topic, next model or topic, infinitive by infinitive form. Here also we apply the L'Hospital rule continuously until we get a finite value. Same procedure, just like 0 by 0 form. Take left hand side value, answer, limit x tends to 0, log x by cot x. Log 0 infinitive, actually minus infinitive, cot x, cot 0. Cot means cos by sine. Cos 0 by sine 0 means infinitive. Don't bother about sine. It is infinitive by infinitive form. So we apply the L'Hospital rule. By applying L'Hospital rule, L'Hospital rule, this limit equal to its derivative. That means limit x tends to 0, log x by cot x is same as limit x tends to 0, log x. Actually, there is a proof using Taylor's theory. This value equal to its derivative value, but proof is not necessary. That's why I am taking just formula, statement as a formula. Log x derivative is 1 by x by cot x derivative is minus cosecant square x. Once again, substitute the x value. Substitute the x value. Substituting x equal to 0, we get 1 by 0 in the numerator minus cosecant square 0. 1 by 0 means infinitive minus cosecant 0 means 1 by sine square 0. 1 by sine square 0 value is 1 by 0. 1 by 0 means infinitive. Once again, indeterminate form. Indeterminate form. Indeterminate form. Here also we get the indeterminate form. So we need one more derivative. So therefore, limit value equal to derivative of the numerator minus 1 by x square minus derivative of cosecant square x equal to 2 cosecant x into tan x, sorry, cot x, minus of minus plus cosecant x into cot x. This is the limit value. Limit x tends to 0 minus 1 by x square by 2 times of cosecant square x into cot x. Cosecant square x into cot x. Okay. So it's better, simple. No need to do all the things. I explain simple way. Here we have more derivative concepts. If you do in the same manner, you always think easiest methods, easiest way to get the answer. This is blind way. Simply take derivative numerator and denominator without any simplification of the expression. So small change. Sorry. Limit x tends to 0. Its derivative becomes 1 by x as usual because 0 by 0 minus cosecant square x. Limit x tends to 0. This is written as 1 by x. This is written as minus 1 by sine square x. It is in the form a by b by b by a. This we get 1 by x into sine square x by minus 1. This expression is written as limit x tends to 0 minus, because you kept usually minus sign in the numerator. So minus limit x tends to 0 sine square x by x. Substitute x value, or don't bother about minus sign. You kept in, you can keep inside also. Minus x tends to 0 means sine square 0. We get 0 by 0 form. Sine square 0 by 0. That equal to 0 by 0 form. Infinity by infinity form converted into 0 by 0 form. Indeterminate. So just once again apply the L'Hospital rule. Therefore, apply the L'Hospital rule. Limit x tends to 0. Here expression is this one. Simplify the above expression, we get this expression. Numerator derivative, minus sign is there, minus half. Numerator derivative becomes 2 sin x into cos x by x derivative 1. 2 sin x into cos x. X derivative is 1. X derivative is 1. So that implies limit x tends to 0. Before we have minus sign. Substitute, otherwise substitute the limit. No need to simplify directly because denominator value is nothing is there. Nothing means 1 is there. Nothing variables are there. Minus 2 times of sine 0 cos 0. Minus 2 times of, because minus is there in front, 2 as well, sine 0 cos 0. Sine 0 0 cos 0 1. 0 into something equal to 0. Here I enter wrongly. Please correct it. This limit value 0, not 1. Limit x tends to 0, log x by cot x is 0. The list also small change. This limit value is 0, not 1. That's why I'm thinking. Next problem. Find other two problems we can do any manner. Any manner means if it is appears 0 by 0 or infinity by infinity, that time we must apply the L'Hospital rule. Otherwise, Here some sign is okay, sign is there, minus sign. Otherwise, you can substitute the expression value. Expression means Taylor series expansion. For example, you will see first problem, second problem for your homework. Try yourself. This is done by two ways. For example, if you substitute x value, what happened? You observe that limit x tends to 0, e power x sin x minus x square by x square plus x times of log of 1 minus x. Substitute x value 0, e power 0 sin 0 minus 0, 0 square by 0 square, 0 times of log of 1 minus 0. Finally, we get a sin 0, 0, e power 0, 1, 1 into 0, 0, minus 0, 0, numerator 0, denominator 0, 0 plus 0 times of log 1 also 0, 0, total 0, 0 into 0, 0, 0 by 0 equal to indeterminate form. Sir, here you may have a doubt. Here you get the 0 by 0 form, but you enter the problem in the infinitive by infinitive approach. This problem also converted into infinitive by infinitive form. This expression is written as 1 by x square plus x times of log of 1 minus x by 1 by e power x into sin x minus. That time we get infinitive by infinite form. Limit extends to 0. You take denominator, numerator 1, x square plus x into log of 1 minus x by 1 by numerator factor e power x into sin x minus x square. Now substitute 1 by 0 infinitive, 1 by 0 infinitive. So we can convert the infinitive by infinitive in terms of 0 by 0. 0 by 0 also converted into infinitive by infinitive. So don't bother both. That's why we apply the same process, L'Hospital rule. So it is difficult. One need to apply the L'Hospital rule. You can apply the L'Hospital rule if you have any interest. This is the first method. So by applying the L'Hospital rule, we get, it may take more derivative also. E power x into derivative of second function cos x plus e power x into sin x, for example, minus 1 minus 2x. 2x mostly if takes more derivative, that time I stop and apply the second method. For the practice purpose, I am telling you, because log of 1 minus x expansion already we know, sin x expansion already we know, e power x expansion is also already we know by using Maclaurin series, Taylor series and Maclaurin series process. By using derivative UV rule, this value is, now substitute once again x value. We get e power 0 cos 0, first term 1, this e power 0 0 minus 1, 2 into 0, in the denominator 2 into 0 log 0 0 minus 0 by 1 minus 0 0, once again 0 by 0 form, indeterminate form. We required one more derivative, that implies limit x tends to 0, derivative of numerator function becomes minus e power x into sin x plus e power x into cos x plus e power x into sin x plus e power x into cos x, 1 derivative 0, minus 2x derivative minus 2. If you know the derivative process, no problem. 2 times of 2x derivative is 2. Log of 1 by x derivative is minus 1 by 1 minus x. Here we need to apply the UV rule. V square into v into derivative of u minus u into derivative of v. It becomes plus 1. Now substitute the x value. That implies e power minus e power plus 0. Exponent is 0. Minus sin 0 plus e power 0 into cos 0, e power 0 into sin 0 plus e power 0 into cos 0 minus 2 by 2 plus minus 1 by 1 minus 0 minus of 1 minus 0 plus 0 by 1 minus 0 whole square. Now once again we get 0 by 0 form. This value 0, sin 0 into anything. Cos 0 value 1, 0 plus 1 plus 0 plus 1 minus 2 by 2 minus 1 minus 1. 2 minus 2 by 2 minus 2, 0 by 0. So we need to apply one more L'Hospital rule. Apply the L'Hospital rule, we get this value equal to limit x tends to 0, e power minus x into sin x, e power x into cos x, UV rule. E power x into cos x minus e power x into sin x. Just I am applying UV rule. E power x into cos x plus e power x into sin x. E power x into cos x minus e power x into sin x. 2 derivative 0 by denominator derivative 2 derivative 0. Here this value becomes 0 minus into minus plus 1 by 1 minus x whole square. In the derivative here numerator x cancel, minus 1 by 1 minus x whole square becomes plus 2 by 1 minus x whole cube. It's the derivative. Now substitute x value, we get the limit value. This value 0, e power 0 into sin 0, e power 0 into cos 0, e power 0 into cos 0, e power 0 into sin 0, e power 0 into cos 0, e power 0 into sin 0. If you have any interest, simplify, then substitute. Most of the time, it is better first to simplify, then substitute. But I am not simplifying and just enter because derivative process, it is easy. If you simplify, sometimes take more time for the derivative process. So whole square, no problem, denominator 2 by 1 minus 0 whole cube. So finally we get in the numerator 0, here minus 1 plus 1 0 plus 1 plus 0 plus 1 0 by 1 plus 2. Minus 1 plus 1 cancel, plus 1 plus 1 2, denominator 3, 2 by 3. So this is the answer. This is one way. Another way you can substitute. I will explain the other method in the regular class. So here I just simply I apply the u by v rule. Similarly, for the next problem, yourself do in the same method. Next problem also you can evaluate. Otherwise, if you know the expansion of 1 plus x whole power 1 by x, substitute and simplify it. That is another method. Here just you apply infinity by infinity form or 0 by 0 form. Next model, third model problems. 0 into infinity or infinity minus infinity. Next model. Next model problem. Type 3. 0 into infinity or infinity into 0 or infinity minus infinity model. Whenever you see these kind of problems converted into 0 by 0 form, simplify the expression, convert into 0 by 0 or infinity by infinity model. If you know infinite, if you get infinity by infinity, it is converted into 0 by 0. You always converted into 0 by 0 form any expression. So 0 into infinity or infinity minus infinity converted into 0 by 0 form or infinity into infinity form. See, first problem in this model. Problem. Limit x tends to 0, tan x into log x. Find limit. Substitute the limit. Actually, you remember, I forgot about the limit definitions. Limit extends to a f of x by g of x. This value nothing but limit extends to a f of x numerator derivative by denominator derivative. This is the definition, not our creation. Similarly, in the product also, limit extends to a. If you have a two product of the functions, f of x into g of x, this time limit extends to a, f of x, limit extends to a, g of x. Give the limit to the both factors. If you have a plus, limit extends to a, f of x plus g of x. This value equal to limit extends to a, f of x plus limit extends to a, g of x. If you have a minus, take minus sign. Plus, plus, minus, minus. These are the definitions. Using these definitions, this limit value is written as limit extends to 0 tan x by, in the previous also we do the same thing, substituting x tends to 0 in the numerator denominator. That means x tends to a in the numerator, x tends to a in the denominator. Tan x into log x. Tan 0, log 0. Tan 0, 0, log 0, minus infinity. 0 into infinity form, either plus infinity or minus infinity, don't bother about it. So indeterminate form. So we convert this expression into 0 by 0 form. So convert this expression, limit x tends to 0, tan x into log x. This is written in the form limit x tends to 0, log x. Tan x is written as 1 by cot x. 1 by cot x. Substituting x equal to 0, we get infinitive by infinitive form, minus this expression equal to limit x tends to 0, log x by limit x tends to 0, cot x, minus infinitive by infinitive. So we apply the L'Hospital rule. Apply the L'Hospital rule. Limit x tends to 0, 1 by x by cot x derivative minus cosecant square x. That implies limit x tends to 0. This is written as minus sine square x by x. Cosecant square x move to 1 by sine square x, a by b, b by c. A by b by c by d equal to ad by bc formula. Already we solved this problem. Infinity by infinity form converted into 0 by 0 form model. Same answer. We get the 0 answer. Limit extends to 0. Substitute limit value. Numerator becomes 0, denominator becomes 0. This is 0 by 0 form. Once again, indeterminate form. So apply the L'Hospital rule to the expression. Sin x derivative 2 times of sin x into cos x. Denominator derivative 1. Now substitute x value. Minus 2 into sin 0 into cos 0 by 1. Minus 2 into 0 into 1 by 1. 0 by 1 equal to 0. Finite 0, it is not 0 by 0. So 0 by finite value equal to 0. Non-zero finite value. So this limit value is 0. Next problem. In our list, you see tan x into log x. Another problem is infinitive minus infinitive model. Limit x tends to 0, 1 by sin x minus 1 by x. Next problem. Type 3, second model. Second model. Find limit x tends to 0, 1 by sin x minus 1 by x. Substituting x tends to 0, we get in the first term 1 by 0 because sin 0, 0. Infinitive minus infinitive. So whenever you see this kind of situation, first we simplify the expression and convert it into 0 by 0 form or infinity by infinity form. That means you take LCM sin x into x in the numerator x minus sin x. Just to simplify this expression, the given limit equal to this expression. So limit x tends to, now substitute the limit, we get 0 by 0 form. Previously x0 minus sin 0 by sin 0 into 0. 0 minus 0 by 0 into 0. 0 by 0. Indeterminate form. This is also indeterminate form. Whenever you see this kind of indeterminate form, this indeterminate form converted into 0 by 0, another indeterminate form format. So, as usual procedure, apply the L'Hospital rule. By apply the L'Hospital rule, then the limit value equal to limit x tends to 0, derivative of the numerator 1 minus cos x by UV rule. First function into derivative of second function sin x into x derivative 1. Second function into derivative of first function cos x derivative. Substitute x tends to 0, we get 1 minus cos 0 by sin 0 plus 0 into cos 0. 1 minus 1 by 0 plus 0. 0 by 0. Once again indeterminate form. So once again apply the L'Hospital rule. Therefore, once again by apply the L'Hospital rule, the limit becomes 1 derivative 0, cos x derivative minus sin x by sin x derivative cos x, derivative of first function into second function minus x into sin x. Substituting limit value, we get 0 plus sin 0 by cos 0 plus cos 0 minus 0 into sin 0. Simplify this expression, 0 plus 0 by 1 plus 1 minus 0. That means 0 by 2. 0 by non-zero finite value is 0. Therefore, this limit value is 0. Third type of problems over. Last type, fourth type. Type 1, type 2, we always apply the L'Hospital rule. In the type 3, always converted into either type 1 or type 2, then apply the L'Hospital rule. Whenever you see the type 1 problem, 0 by 0 problem, we apply the L'Hospital rule. Whenever you see the type 2 also, we apply the L'Hospital rule. Otherwise, converted into 0 by 0. Type 1 problem, apply the L'Hospital rule. Type 3 also, whenever you see 0 into infinity or infinity minus infinity, converted into, simplify the expression and converted into 0 by 0 or infinity by infinity. Infinity by infinity converted into 0 by 0, no problem. So then after conversion, we apply the L'Hospital rule. Here, type 4, it is different from other type, small variation. There are, in type 4 problem, there are 3 types of situations. 1 power infinity, infinity power 0, 0 power 0. There are 3 situations. There are 3 situations. 0 power 0, 0 power 0, 1 power infinity or infinity power 0. We'll take one problem. So apply the log. So whenever you see, for example, limit x tends to a f of x, this value after substituting limit, we get 0 by 0 form. That time you take, let, second step is let y equal to f of x. This is the next step. Immediately, whenever we get the 0 power 0, 1 power infinity, infinity power 0 limit values, or 1 power infinity or infinity power infinity, that time first step is given function taken as y. Then apply the step 2. Take a limit. sorry, log. That means log y equal to log f of x. Usually here f of x into g of x. Then only we get a exponent 0 power 0, 1 power 0, infinity power 0. That means let y equal to f of x power g of x. Take a log on both sides. It becomes g of x. That implies log y equal to g of x into log of f of x. Log a power b equal to b times of log a. This is the value. Later, this value may be 0 into infinity form, something, or finite into finite. After that, we required y value. Keep y and move log other side. We get e power g of x into log f of x. Now take limit. Y nothing but this expression. We require the y value. Same expression. This is the way. One more time. Given function taken as y, then apply the log. After applying the log, take a limit. And after that, we required y value, not log of y. So log, take a log inverse of the log. Inverse of the log means exponential. This is the way. We will see the problems based on fourth kind. Problem 1. Limit x tends to pi by 2 sin x whole power tan x. See, f of x power g of x. If you substitute this value, sin pi by 2 whole power tan pi by 2. Sin pi by 2, 0. Tan pi by 2, 0. 0 power 0. So this is fourth type of indeterminate form. So we apply our technique. Let y equal to, no L'Hospital rule. Just let y equal to sin x power tag x. Whenever 0 by 0, infinity by infinity, or 0 into infinity, minus infinity, that time we convert 0 by 0 form and apply the L'Hospital rule. Whenever you see the exponential form, just 0 by 0 or 1 power infinity or infinity power 0 we get. That time take given function equal to y. Take log y equal to log of sin x whole power tan x. By the logarithmic property, this value becomes tan x into log of sin x. That implies log y equal to tan x into log of sin x. So substitute the limit, we get a tan 0, log of sin 0, 0 into infinity form. So if you have any confusion, convert y equal to e power tan x into log of sin x. Y means sin x whole power tan x. Y we choose as sin x whole power tan x. E power tan x into log of sin x. Take a limit on both sides. X tends to pi by 2, not 0. E power tan pi by 2. Oh, here I enter wrongly. This is not 0 by 0 form. Tan sin pi by 2, 1. Tan pi by 2, sin pi by 2 by cos pi by 2, 1 by 0, infinity. This is 1 power infinity form derivative. Anyhow, value is wrong, 0 power 0, I enter 1 power infinity value. But for any situation, either 0 power 0, 1 power infinity, infinity power 0, same procedure. Take y equal to function and take a log and y, find y value. in terms of exponential, then take a limit. Tan pi by 2 into log of sin pi by 2. E power tan pi by 2 infinity. Log 1 sin pi by 2 1. Log 1 is 0. Infinity into 0 form. So we need to apply L'Hospital rule, not L'Hospital law, converted into 0 by 0 form. So in the exponent, you see indeterminate form. Third category. So whenever you see the third type converted into first type, therefore limit extends to pi by 2 sin x whole power tan x, limit extends to pi by 2 e power tan x into log of sin x. This is converted into 0 by 0 or infinity by infinity form. E power, keep sin x log x as usual. Tan x sent to down, it becomes cot x. It becomes 0 by 0 form. Cot pi by 2 is 0. 0 by 0 form. Now we apply the L'Hospital rule in the numerator. That means this value equal to e power limit. Limit move wherever expressions are there. Cot x. 0 by 0 form. Substitute the limit, we get pi by 2 log sin pi by 2, sin pi by 2 1, log 1. Log 1 means 0. Cot 0, cot pi by 2. Cot pi by 2 means, cot means cos by sin. Cos 0. Cos pi by 2 minus sin pi by 2. Cos pi by 2 0. 0 by 1 means 0. So it is 0 by 0 form. So apply the L'Hospital rule. By applying L'Hospital rule, this value equal to limit extends to infinity. Log of sin x becomes 1 by sin x into sin x derivative cos x. This is the expression for the derivative of log of sin x. Derivative of cot x. Already we see the derivative of cot x minus cosecant square x. Simplify the expression. E power limit extends to pi by 2, not 0, pi by 2. Simplify this expression 1 by sin x. Move 1 sin x numerator. It becomes sin square x into cos x by sin x. 1 sin x, 1 sin x get cancelled. Finally, we get e power limit extends to pi by 2 minus sin x into cos x. Substitute the limit value. E power minus sin pi by 2 into cos pi by 2, which is equal to e power minus sin pi by 2 0, cos pi by 2 1. E power 0. E power 0 equal to 1. Therefore, its limit value is 1. Next, one more problem in this model. Find limit extends to 0, a power x plus b power x plus c power x by 3 whole power 1 by x. So substitute x equal to 0, we get a power 0 plus b power 0 plus c power 0 by 3 whole power 1 by 0. A power 0 plus b power 0 plus c power 0 becomes 1 plus 1 plus 1. 1 by 0 means infinity. 1 power infinity. So indeterminate form. So therefore take answer. Take y equal to given expression a power x plus b power x plus c power x by 3 whole power 1 by x. Immediately take log on both sides. Log y equal to, here I am writing directly 1 by x times of log of a power x, b power x plus c power x by 3. Apply the limit value. Limit extends to 0. What happened in both sides? Extends to 0, 0. Here 3 by 3 log 1. This is written in the form log of a power x plus b power x plus c power x by 3 by x. 1 by a into c. This is nothing but b by a. That's all. Clearly apply the limit. You can apply here only, or after converting in terms of exponential, also we can apply the limit. If you have any confusion, convert in terms of exponential. Take log inverse on both sides. Log inverse becomes y. Here it becomes exponential. Log inverse is exponential function, e power of a power x plus b power x plus c power x by 3. Oh, by x. Therefore, y equal to e power of log of a power x, b power x plus c power x by 3. This is numerator. Denominator is by x. This is the expression. Now, limit of x tends to 0, y equal to limit of x tends to 0. This limit value is a power x, b power x plus c power x whole power 1 by x, because y value is this one. This y value is same as another expression. Y has two expression. We start from y equal to this expression. Finally, y value in terms of exponential. That means both have the same form. Both are equal. A equal to b, a equal to c, then b equal to c. E power log of a power x plus b power x plus c power x by 3 by x. Substitute the limit. We get to infinity limit x tends to 0 log of a power x b power x plus c power x by 3 by x. Substituting this limit, we get 0 by 0 e power log of a power 0 b power 0 plus c power 0 by 3 by 0 e power log 1 by 3, sorry, log 3 by 3 by 0. E power 3 by 3 means 1, log 1 means 0 by 0, indeterminate form. So take L'Hospital rule. Therefore, limit x tends to 0, y means a power x, b power x plus c power x whole power 1 by x. This value equal to L'Hospital rule of this expression. Limit x tends to 0, e power. If you have any confusion, take L'Hospital rule on the exponent. Limit x tends to 0. By applying the L'Hospital rule, what is denominator is 1. Okay, happy because x. What about derivative of this expression? Numerator expression. We have a logarithmic expression. Which is equal to e power limit x tends to 0, 1 by a power x plus b power x plus c power x by 3 into derivative of a power x. If you have any confusion, d by dx of a power x. Let y equal to a power x. Don't feel this y and this y are same. Just assumption. Take a log y equal to x become x into log x. Now its derivative log a. Dy equal to y times of log a. That means y equal to a power x. A power x into log a. We get a power x into log a plus b power x into log b plus c power x into log c. This is the numerator derivative. By denominator derivative is 1. Apply the limit value e power 3 by, if you convert 3, it is going to numerator a power 0 plus b power 0 plus c power 0 into, apply here a power 0 log a plus b power 0 log b plus c power 0 log c, which is equal to e power 3 by 3. Simplification your choice. If you have more experience, you can simplify easily. Otherwise, it takes some time. E power 3 by 3 into log a plus log b plus log c equal to log a b c. 3 get cancelled. E power log of a b c. Log exponential becomes a b c. That's all. So this is this another problem in this model. So last problem in this model and stop the concept. Last problem in this model. Limit extends to 0 tan x by 3 whole power 1 by x square. Tan x by 3 whole power 1 by x square. Substituting 0, 0 by 3, 0, 1 by 0 square means infinitive. 0 power infinitive form. Tan 0, 1 by 0 square, 0 power infinitive form. So it is, we need to apply L'Hospital rule. Not L'Hospital rule. Convert this expression into y form. Take y equal to tan x by 3 whole power 1 by x square. Take a log on both sides. Log y equal to 1 by x square times of log of tan x by 3. Now substitute the limit value. We get a 0, 1 by x square becomes infinitive. Log 0 infinitive, infinitive into infinitive indeterminate forms they are. So convert this limit, or it is written in the form log of tan x by 3 by x square. Tan x square. What happened? So it is actually it is not fall in our model. Our indeterminate form is 0 power 0 or 1 power infinitive or infinitive power 0. This is not in our fourth model. Okay, stop this process and apply the other way. This problem is not fall into our model, even we have an exponent. So it is better to simplify this expression in another way, because this is not fall in our four given models. But I mentioned in the fourth type, even though it is not fall into the fourth model. So we apply the another approach. Another approach means simple. Substitute the expressions, trigonometric Maclaurin series expressions. So apply the Maclaurin series expression for the tan x. This limit equal to limit extends to 0. Tan x expression is x plus x cube by 3 plus 2 by 15 x power 5. Next we get x power 7 with some coefficient. Just you keep remember at least these three terms in the Taylor series expansion by 3 whole power 1 by x square, whole power 1 by x square. Okay, that implies let x tends to 0. Here problem itself wrong. That's why we get the wrong. Maybe I choose here x. That's why 3. See in the typed question, it is better. The typed question I enter wrongly. Not 3 x. Sorry, not 3 x. So now okay. It is fall into fourth model. Otherwise, anyhow, I explain in this way. Take x as a common factor in the numerator. It becomes by x whole power 1 by x square. X cancel. I will explain fourth model type also, same problem. That implies limit x tends to 0. It appears x square by 3 plus 2 by 15 x power 4 plus and so on whole power 1 by x square. You write down this expression in the form limit x tends to 0. 1 plus take x square as a common factor. X square into 1 by 3 plus something. Other terms. Take a x square is a common factor from second term onwards. This is taken as a t. That implies limit x tends to 0. 1 plus x square into t whole power 1 by x square. Whole power 1 by x square. So already we know that limit x tends to 0. 1 plus x whole power 1 by x equal to e. We convert this. Here we have x, here we must have x. Here we have x square t, here we have x square only. So convert this expression in this form 1 plus x square t into 1 by t into x square into t into t. T get cancelled, we get 1 by x square. So send the limit inside. This value becomes e. Limit x tends to 0. 1 plus x square t whole power 1 by x square t whole power t. This value is e power t. As limit t tends to limit apply for t also because t contains variable. T expression in terms of x. See. If you have any confusion, please write down. This value equal to t times. T times means limit x tends to 0. T also involved x. That means you apply the limit for both. For both means if you have any confusion, apply limit here also. Limit x tends to 0. This value is e. E power limit x tends to 0. T value is, you see, 1 by 3, 1 by 3 plus something. 1 by 3 plus all are involving x. 1 by 3 plus 2 by 15 into x square plus and so on. Other terms involving x. Substituting x equal to 0, all terms becomes 0 except the first term. That implies e power 1 by 3 plus 0 and so on. That implies e power 1 by 3. That's all. This is without applying any our models. Using our models, we can solve this same problem. Tan x by x whole power 1 by x square. Limit x tends to 0. What about 0 by 0? Tan 0, 0, 0. It is 0 by 0 whole power 1 by 0 square. Infinitive. 0 by 0 is not determined. Don't put infinitive. 1 by 0 square means infinitive. It is also not fall in the our model. That's why they apply the expansion, simplify the expression. Or if you have any interest, this is also converted into our required model. Tan x sent to down. It becomes tan x becomes cot x into x whole power 1 by x square. Cot 0, cos 0 by sin 0, infinitive 0, infinitive into 0, 1 by infinitive. So infinitive into 0 always converted into infinitive by infinitive or 0 by 0. So once again, it is not a proper form of our required models. So don't go for our models. It is better to stop here only. Mostly, not only mostly, 99% of the indeterminate forms of the problems I covered. Only 1 or 5% left for you as a exercise. Then regular class I will cover the other part.